Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to see about discrete Fourier transform. So discrete Fourier transform, it is used to convert a time domain signal into frequency domain. So for normally signal processing applications, this is the best transform that will be used for converting the time domain to frequency domain. Formula for this DFT computations. So x of k equal to summation of n equal to 0 to n minus 1 x of n into e power minus j 2 pi k n divided by n, where k should be calculated from 0, 1, 2 up to n minus 1. So here this e power term that will be called as a tittle factor, and x of n will be an input time domain signal, and x of k that will be an frequency domain outputs. So the inverse transform of discrete Fourier transform that will be given as IDFT of x of k is given by x of n equal to 1 divided by n summation of k is equal to 0 to n minus 1 x of k into e power j 2 pi k n divided by n, where n should be calculated from 0, 1, 2 up to n minus 1. This is inverse Fourier transform. So the first formula will be used for converting from time domain to frequency domain, and then second formula that will be used for reversing of that frequency domain to time domain conversions. Look at this tittle factors. We can use this tittle factor W of 4 that will be useful for computations in an easy manner. Look at this W0 of 4 that will be taken as this e power minus j 2 pi by 4 into this is kn will be multiplied, so that will be 0 here. So this 0 will be substituted here. So e power 0, so that will be equal to 1. And look at this W4 of 1. So e power minus j 2 pi 4 into W1. So this 1 will be substituted here. So if you multiply it, what we get means, so e power minus j 2 pi by 4. So 2 and 4 will be cancelled. We get e power minus j pi by 2. So this is an e power minus j theta. So if we expand it, we get a cos theta minus j sin theta. So instead of theta, we have the value of pi by 2. So we get cos pi by 2 minus j sin pi by 2. So cos by 2 pi by 2 value will be 0 and sin pi by 2 value will be 1. So 0 minus j into 1, you get a minus j. Look at this W24. So this is e power minus j 2 pi by 4 into 2. So because it's a W4 of 2. So 2 into 2 will be 4. 4 will be cancelled. You get only e power minus j pi. So that will be equal to cos pi minus j sin pi. So theta will be equal to pi here. So cos pi value will be 1, sin pi value will be 0. So you get final answer as 1. Look at this W34. So this will be e power minus j 2 pi 3 into divided by 4. So we get the 2 into 4. So 2 and 4 can be cancelled. You get by 2. So e power minus j 3 pi by 2 we get it as a theta. So that will be expansion will be cos 3 pi by 2 minus j sin 3 pi by 2. So that will be equal to, for cos 3 pi by 2 that will be 0, sin 3 pi by 2 that will be minus 1. So minus 1 into minus j, you get a plus j here. Look at this W4 of 4, e power minus j 2 pi into 4 divided by 4, 4 will be cancelled, you get e power minus j 2 pi. So this will be equal to cos 2 pi minus j sin 2 pi. So this will be cos 2 pi value will be 1 and sin 2 pi value will be 0. So you get a final answer as 1 here. We'll look at this construction of W4. So all combination we need to take it. So this will be W0 of 4 and W0 of 4, all this row and column. Here look at this W4 of 1 and this is W4 of 2 and this is W4 of 3 and this is W4 of 2 and this is W4 of 4 and this is W4 of 6. Here W4 of 3 and this is W4 of 6 and this is W4 of 3. So this is a k value and this is n value. These two multiply and that will be put here. Look at this 0, here also 0. So 0 into 0 that will be 0 here. So 0 into 1 that will be 0 here. Again 0 into 2 that will be 0 and 0 into 3 that will be 0. Similarly look at this 1. So 1 into 0 will be 0 and 1 into 1 will be 1 and 1 into 2 will be 2 and this 1 into 3 that will be 3 here. Look at this 2. So 2 into 0 will be 2. 2 into 0 will be 0. 2 into 1 will be 2 and 2 into 2 will be 4 and 2 into 3 that will be 6 here. Look at this 3 that should be multiplied with this. 3 into 0 will be 0. 3 into 1 will be 3. 3 into 2 will be 6 and 3 into 3 that will be 9. So each value we need to calculate it and that will be replaced here. So W04 will be 1. So all here that value will be put here. and W14 value will be equal to, look at this, minus j. So here this is minus j, we are putting it, and then remaining values. So this is W24, this is also W24. So W24 value will be 1. So we replace that values here. And this is the W34, and this is the W44, and this is W64. So the corresponding values will be replaced. We get a W4 will be equal to this matrix. So this is for a 4-point DFT computations. If we go for a 8-point DFT, we need to calculate for a W8. So if we want to go for a 16-point, we go for a W6 points. So we need to calculate for a different values of k value and n value. Once if we construct it, we can directly use this matrix to multiply and get the answer.